All right. So I was asked to do number 7, and this is a challenging one because you have to actually use the quadratic formula. So let's go ahead and try it out. So at a circus, a clown is shot out of a cannon at 15 meters per second. So let's go ahead. Let's write our knowns. We have the initial is 15 meters per second. Then you have the cannon is 2 meters off the ground and set at an angle of 40 degrees. So the height of the cannon is 2 meters and the angle is 40 degrees, right? The clown then lands in a flower pot that is 1 meter off the ground. So the height of the pot is 1 meter. Let's go ahead. Let's write out our assumptions. Let's assume that up and to the right is positive, down and to the left, I don't like the way I did that, down and to the left is negative. And let's say that no air resistance. Right, there's no air resistance. That's another assumption. Let's go ahead, let's draw it. We have our cannon. Boom. Right there. And it's 2 meters high. Then we have our flower pot, which I may have drawn as a pool in the solutions because that's the original question that I edited. Right? So this is our flower pot. And then this is our little clown. Right? So our clown is going to be shot up and he's going to land right into this flower pot. The flower pot is 1 meter high, right? So let's solve for everything. What are we missing? We're missing V final, max height. What else are we solving for? We know acceleration is gravity. It's 9.81 meters per second squared, right? Is there anything else we know? Boom. Oh, we're missing time, right? And we're missing displacement. Okay, so that's everything. Let's go ahead and let's do our triangle. I'm going to go ahead and I'm going to do the triangle on top of the drawing. So we're being shot out at an angle of 40 degrees from the horizontal, right? This is 40 degrees. That means that this is V naught T, right? So then our half AT squared has to go to where we ended, right? So if our displacement vector starts from the cannon and ends at the flower pot, this is our entire displacement vector. That means that our half AT squared has to go all the way down. Just like this. So we have the way we're initially being shot. We have from where we began to where we ended. And then we have the change, which is half AT squared. Right? So if we were to plug in everything we knew, I'm going to go ahead. I'm going to draw the triangle again over here. V naught T. Then we had a dotted line across. Half AT squared went down. This here was 1 meter. And this was our displacement. So displacement, half AT squared was this entire side. Okay. So, and this was 40. Oops. Don't want to get that confused. That's 40. Okay. So, with this, let's go ahead and let's try to turn this into a right triangle. If we know that the distance of this little height is 1 meter, we can actually solve for the displacement in the x by just subtracting that 1 meter from half AT squared. So if we subtract that 1 meter, we actually end up with a right triangle. That didn't do what I wanted it to do. There we go. So we'll end up with a triangle that says v naught t half a t squared minus 1. And then our line on the bottom would be our displacement in the x. We know that our displacement in the y would be the 1 meter that we changed, right? So we went down 1 meter. So now with this, we have a right triangle. So let's go ahead and solve. We know that our v initial was 15, but we don't know our time. Half is just a number. 9.81. 9.81 is our acceleration. Then we have t squared, which we don't know, minus 1. And we don't know our d and x. So let's see our unknowns. We're missing t, and dx. So what can we do? Obviously, we can't solve for dx because these have t. But what we can do is use both the side of v naught t and the side of half a t squared because they are missing the same variable. So let's go ahead and let's do that. That would be sine, right? So sine is opposite over hypotenuse. Let's go ahead. Let's change the color. Let's use this. Okay. So sine of 40 is going to be opposite, which is half a t squared minus 1 over v naught t. We can go ahead and replace that. We get sine of 40 degrees is equal to half 9.81 t squared minus 1 over v naught, which is 15 t. So what happens here is the fact that this has both t and t squared. So if we were to move things around, we'd still end up with sine 40 times 15t equals half 9.81 t squared minus 1, right? But what happens is we cannot divide by t, because if we divide by t, we also have to divide the 1 by t, and we end up with the same problem. So what we actually end up doing is we move the 1 over, and we end up with 15t sine 40 minus 1, right? Equals half 9.81 t squared. And then we go ahead, we multiply by 2. So we get 2 times 15t sine 40 minus 1 divided by 9.81. So we multiplied the 2 divided by the 9.81. And then, by 9.81 t squared. Oh, wait. I messed up. Oops. Sorry. Ignore that. I'm not going to restart the whole video. So, actually, what we end up doing is we equate it to 0. So, we end up with half 9.81 t squared plus 15t sine 40 minus 1. Minus 1 equals 0. So when we do this, right? When we use this, when we see something like this is in the format of ax squared plus bx plus c equals 0. This is a quadratic, right? It's a polynomial, quadratic. So we're going to use a quadratic equation, right? So we would use A negative boy couldn't decide to go to a radical party. The boy sweared he missed out on 4 awesome chicks. It was all over by 2 a.m. So this is our quadratic formula, right? This is going to give you x, and it's going to give you 2 answers because there's a degree of 2. So we're going to get 2 answers, right? So when plugging into this formula, we would end up with all of this as A. 15 would be B. Oh, no, 15 sine 40. Here, let's go ahead. Let's move this. Oops. Let's go ahead and do this. This is sine 40. We'll put this next to the 15 because multiplication is commutative. So the 15 sine 40 is B. And then negative 1 is C. Oh, it's actually positive. Sorry about that. Because it's negative up here. We subtracted the 1, so it became a positive. Sorry about that. Hope somebody caught that. So this ends up being positive 1. So this is C. Okay. So you ended up with A as half of 9.81. B as 15 sine 40, which is a number, obviously, that if you plug it into the calculator. And then we have C, which is 1. Now, if you plug that all in, you're going to see that you get X or T. No, why did I undo solve? Okay, so you're going to get T equals... T equals negative 0.09877 and T equals 2.06 seconds. Now, can time be negative? No, right? So this is not our answer. Our time is 2.06 seconds. So it gave us 2 answers. Only one works. So we had our 2 answers. Only one works. We know that T is 2.06 seconds. Now, this was the hardest part of the entire problem. The rest is going to be plug and chug. And if you chose to use components, you have the same situation, right? Let's say we're going to use D equals V naught T plus half AT squared. The total, and let's do it with our Y's, right? Because we're using components. V initial in the Y, half AT squared in the Y. We know that half of 9.81, right? T squared. And then V naught Y is going to be to find the initial in the Y, right? So this will be V initial. This will V initial in the Y. This is V initial in the X. This is 40. So V initial in the Y is sine of 40 times the hypotenuse, which was 15, right? T. And then the displacement in the Y. What was the change in the Y? From here to here. 1 meter. So minus 1 meter. What did we end up with? This looks all familiar. So let's see. Let's turn it into a quadratic again. 0. Move this around. We get half 9.81 T squared plus 15 sine 40 T plus 1. We ended up with the same exact equation. Same thing. AX squared plus BX plus C, where we have C, B, and A. So that means that we're going to end up with T equals 2.06 seconds again when we plug it into our calculator. So once we find our time, right, life gets a lot easier. Now, what we can do is, what do we want to solve for first? We have our time. Let's solve for our displacement in the X. So for our displacement in the X, if we use our triangle, using our triangle. I'm going to redraw it here. This was half at squared minus 1. This is v naught t. And then this was our displacement in the x. So, in order to solve for our displacement in the x, sorry. In order to solve for our displacement in the x, I'm going to choose to do, you can use Pythagorean theorem, you can use multiple different methods, you can use kinematics using components. So what I'm going to choose to do is I'm going to use cosine. So cosine is adjacent over hypotenuse. So cosine of 40 is equal to adjacent, which is dx, over hypotenuse, which is 15 times 2.06, right? So then if we have 15 times 2.06, let me go ahead and do that math. I had the quadratic set up earlier. Second quit. Let's go ahead and let's move this over. So 15 times 2.06 cosine 40 equals dx. Cosine 40 times 15 times 2.06. So our displacement in the x was 23.67 meters. That's our displacement in the x. Now we know our displacement in the y was negative 1 meters, right? So that means we went over 23 and we went down negative 1. So what's our total displacement? We're going to use Pythagorean theorem. So 23.67, right? Squared plus 1 squared. And then we're going to go ahead and we're going to square root that answer. And we end up with 23.69. So that means the displacement total was 23.6918, whatever. So this is our total displacement. And we found that. I didn't write it out. I just said it. We found that using a squared plus b squared equals c squared. So it was 23.67 squared plus 1 squared. Well, technically, negative 1 squared equals c squared. All right. So then we square rooted both sides and we were able to solve for our displacement total. So we were able to solve for our displacement total, so 23.69. Now look at that. All we're missing is our V final and our max height. We can solve for our V final using either our triangle, which is a little more complicated, or we can use components. So let's go ahead and let's use components. V final, we know that V final minus V initial over time is equal to our acceleration, right? We do not know our V final, but we know our V initial in the y. We're going to do all of these in the y, right? And we know that our V final in the x is equal to our V initial in the x because there's no acceleration in the x. So let's go ahead. We know that we don't know our V final in the y, but we know that acceleration was 9.81 negative, right? Oh, by the way, I plugged it into my calculator as a negative, but I didn't plug it in here. That's a negative. Sorry. Okay. So negative 9.81. And then we have, that's acceleration. We're going to multiply it by time. So multiply time over. We end up multiplying it by 2.06. Then we're going to add our V initial in the y to cancel that over here. So V initial in the y. And we are going to end up getting Our v initial in the y was 15 sine 40, as we did before. Let's go ahead. Let's plug it into our calculator. 9.81 times 2.06 plus 15 sine 40. We're going to get our v final in the y is equal to 29.85. Oh, I didn't put a negative. Correction. I did not plug in my negative. Try that again. Negative. Now we got negative. There we go. That makes more sense because it's moving downward. We got negative 10.56678, right? Meters per second as our v final in the y. Our v initial in the x was cosine 40 times 15, right? So that is going to be 15 cosine 40. We're going to have 11.49 meters per second in the x. So once again, we're going over 11.49. We're going down negative 10.5668, whatever. And then our final is going to be oh, wait, wrong button. That means that if we use, a squared plus b squared equals c squared, we're going to end up with our velocity final total to be there you go. Boom, squared. Once we have it's a squared plus b squared, we're going to take the square root, second square root, 243. You're going to end up with the final total being 15.61 meters per second. Okay, so our v final, and it's going to be in this direction, over and down. Right? So we have our v final, it's 15.61, which makes sense. It only displaced 1 meter, so it should be slightly faster. 15.61. Now our max height. What can we do for our max height? Once again, I would suggest using components. You can use the triangle method if you really want to. But to solve for the max height, we know that at the tippity top, our v final in the y is going to be 0. Right? So if we do v final minus v initial over time equals acceleration, right? We're going to be able to solve for it. But we don't have our time, right? Our time is missing. So can we use our other formula? D equals v naught t plus half a t squared. Okay. So we're missing 2 in both. We know our v initial, we know our acceleration, but we don't know our time. We know our v initial, we don't know our acceleration, but we know our v initial, we know our acceleration, we don't know our time. What we can do is we can substitute in for time, right? So if we substitute in for time, we can say that time is equal to v final minus v initial over acceleration, right? If we go ahead and we plug this in here, you end up with d equals v naught in the y, obviously. These are all in the y. T is going to be v final minus v initial over acceleration, which is 9.81, plus half acceleration times our time squared, and we plugged in for our time We plugged in for our time. V final minus V initial over acceleration. Oh, wow. I must be very sleepy because I am very dumb. We know our V final is 0. And we knew our V initial. So we don't have to do that. We can leave these as time. I'm sorry. You can also just plug straight in there to get the... I must be very sleepy. It would have worked either way. But let's make our lives easier. We do know V final. And hopefully you guys caught on to that. And your brains are more awake than mine. But... we do know V final. V final is going to be 0 at max height. Because that's what we said earlier. Right? Right here. My dumb little brain. Then we have our V initial. We don't know our time. But we know our acceleration. So let's go ahead. Let's multiply time. Divide by A. We're going to get negative V initial over acceleration is equal to time. Okay, so I accidentally locked my iPad, stopping the video. But my bad. Here we go. So we were able to solve for negative V initial over acceleration equals time. Right? Go ahead, and what we're going to do is plug in our negative V initial, negative 15 sine 40. Right? Over negative 9.81 is going to give us the time to our max height. Right? This is max height. Max height. Let's go ahead. Let's plug it in. We have 15. So wait, I got alpha y equals frac. Okay. 15 sine 40 over 9.81. The negatives are going to cancel out. It took 98.28 seconds. Oh no. 0.9828 seconds. Sorry. To get to the max height, which is less than half of the time, which makes sense because it traveled lower than where it began. So this would be our time for max height. Now if we just go ahead and plug that back into our displacement in the x, displacement in the y. Displacement in the y is going to be v naught y, which is 15, 15 sine 40 times the time we just solved for, 0.98 plus half 9.81 times t squared, which is 0.98 squared. So if we go ahead, plug that in, 15 sine 40 times 0.98, right? Plus 0.5 times 9.81, negative 9.81. I gotta get better at these. I keep dropping them. Negative 9.81 times 0.98 squared. You end up getting with your max height. Max height ends up being 4.738 meters. And with that, you have officially solved for everything. It's 4 point something. 4.738. And hopefully that helps you guys with this problem. The most complicated part of this problem is genuinely just the beginning where you had to use a quadratic. The rest is just plug and chug like every other problem.